You are a highly qualified engineer. You sit in an automated video interview and deliver an accurate solution to a complex systemic prompt. Your math is correct, your logic is sound. And yet, the moment you finish speaking, the automated recruitment platform rejects your application. This failure stems from a psychological misconception. Most candidates look at the digital avatar on their screen and assume they are speaking to a conversational entity, a listener that understands human context and social cues. In reality, your technical proficiency cannot be verified if your speech format does not match the machine's strict evaluation interface. Behind the avatar, the AI interviewer operates as a high-speed speech-to-text transcription engine. It does not evaluate your confidence. It processes a text document. This illustrates how your words are categorized. As your voice enters the digital funnel, the system evaluates your semantic density, the ratio of specific technical action verbs to vague filler language. When you say like, or you are using social habits to signal that you are thinking. The parser reads these as literal syntax errors in the text string. Every filler word included in your answer physically dilutes the semantic density of the final transcript, increasing the distance between your actual points of evidence. This turns natural conversational rhythm into a mechanical liability for the grading algorithm. To understand why this transcript matters, we have to look at how the algorithm grades the generated text. The system uses chain-of-thought processing. It is programmed to find a continuous, logical path from the problem statement to the final result. It scans the text for structural markers, the definition of the problem, the specific action taken, and the measurable outcome. This process relies on syntactical joints. Using words like because, therefore, and assuming provides the markers the algorithm needs to connect these three data nodes. A structured answer provides these joints where the machine expects them, allowing the system to verify methodology. The evaluation is a test of structural integrity, checking if your logic is properly formatted for the machine to parse. Consider a specific scenario. You are diagnosing a database latency issue in a production system. You know the solution, but you deliver it with conversational hesitation. Well, the latency issue is probably caused by the sync, so I guess I would run a background sync. The algorithm plots your technical keywords as coordinates within the transcript document. The parser relies on spatial proximity. It needs the problem node, latency issue, and the solution node, background sync, to appear near each other to establish a relationship. By injecting multiple filler words, you force your data points outside the algorithm's acceptable proximity threshold. The system attempts to draw a logical line between these 2 points. Because of the spatial gap, the points remain disconnected. The system fails to register the relationship between your problem statement and your solution. You provided the correct technical information, but the machine recorded a logic gap. In this context, filler words are a form of data corruption that prevents the machine from reading your reasoning. If rambling causes a spatial gap, the intuitive human reaction is to remain silent while you formulate your next sentence. This triggers a different platform mechanic, voice activity detection. This monitor follows a mechanical rule. Sustained silence is interpreted as a signal that you have finished speaking. If you pause for several seconds to think, the system may abruptly cut the microphone and terminate your answer before you can deliver your conclusion. A human interviewer uses visual cues to understand you are thinking. The AI platform relies entirely on audio input to manage the flow of the conversation. Treating the microphone as a patient listener can lead to an incomplete transcript. To navigate these conflicting requirements, you must use meta-narration, or speak-to-pause phrasing. This involves stating your internal processing out loud. By saying, "I am evaluating the constraints of this database," you provide continuous audio to the microphone. This audio prevents the voice activity monitor from cutting you off, while avoiding the use of filler words that are served with additional structured logic nodes that describe your thinking process. Managing the AI interview becomes an active process of data entry, rather than a casual conversation. We can see the impact of these strategies by comparing 2 identical technical solutions evaluated by the system. On the left is the corrupted transcript. Spatial gaps are wide, logic nodes disconnected by filler, and the system cannot verify the answer.
On the right, the optimized transcript uses syntactical joints to build a clear pathway. The algorithm validates it, generating a passing score. Success in an automated evaluation depends on feeding the algorithm data in a format it can recognize. Adapting to this interface requires significant effort. It can feel unnatural to strip away the social habits of conversational speech. However, this mechanical restriction forces a specific focus on structural clarity and the removal of vague language. Organizing thoughts into a strict sequence for an algorithm is a form of practice. The same logic used to satisfy a transcript parser can be applied to high-stakes human communication, such as briefing a technical team or presenting a proposal to senior management. Mastering the structure required for an algorithm provides a framework for